everyone. Today we are going to see how to find the z transform of a given equation. The given equation here is x of n is equal to alpha raised to n and u of n. To calculate the value of the z transform, we have a formula for z transform. X of z is equal to summation of n is equal to minus infinity to plus infinity x of n into z raised to minus n. This is the formula. We have a question, this one. Now we will substitute the given question. Before starting, just I'll give you the brief introduction of the z transform. Z transform is the discrete time counterpart to the Laplace transform. Basically, a z transform in engineering practice are the study of system characteristics and derivation of the computational structures for implementing discrete time systems on computers. It is you can say DTFT does not converge, but the Z transform converges. So this is the application why we are going for a Z transform. The set of Z, what will you get? That will be converges. Where it converges, that is called as region of convergence. The range of R for which this condition is satisfied is called ROC. That we are going to draw in this problem. So to solve this, we'll substitute the value of x of n which is given in the question. So summation of n minus infinity to plus infinity alpha raised to n. So we have value alpha raised to n into u of n value is 1. You know the unit response value is 1. So into z raised to minus n. Now you can take n power common here, so it will become n equal to minus infinity to plus infinity alpha. So z inverse remains and the n will be the total power which is common. Suppose this is the first equation. Now to calculate, to find out this value, we have one formula which is infinite sum formula. N equal to 0 to infinity alpha raised to n is equal to 1 by 1 minus alpha. So this is the formula for condition alpha is less than 1. So we have this formula. Now comparing this equation, that is the formula standard, with the first equation, we can write x of z is equal to 1 by 1 minus alpha z inverse, because our alpha is alpha z inverse. So for this condition, we have if alpha z inverse is less than 1. So in place of alpha we have this, or you can write this one as, if you take the reciprocal, if you take the z inverse in denominator, if you're taking the LCM, z goes up, z divided by z minus alpha. This will be the ROC, that is z must be greater than alpha, otherwise it will be infinite. So z must be greater than alpha because z minus alpha it is. To draw the region of convergence, we will draw the two lines. One is x-axis, another y-axis. X-axis is the real part of the z and y-axis is the imaginary part of the z. So we'll draw a circle, unit circle. So already I said you the r, the radius, the range of r should be drawn. Now you need to find out z, that is the set of z is greater than alpha. So that means, suppose this circle is of radius r, so the region of convergence are, I'll show with this shaded region. This is the shaded region which is the outside the circle. This is the region of convergence, which is the point alpha. So that means it is outside the circle. So that is the region of convergence for this problem. For more problems in the Z transform, please do watch our channel and please subscribe our channel. Thank you everybody.